So hopefully you've mastered that last lesson on prime factorization, because now it gets really tricky when we're looking at prime factorizations of two different numbers and seeing how we can use the prime factorizations to our advantage. So this is now lesson 1.3 on prime factors. Prime factorizations of two different numbers to find common factors and common multiples. So the first thing we're going to do is let's look at this question. Show what is the greatest common factor and the least common multiple of the numbers 36 and 48. Well, let's start off separately, and let's make it very simple and just separate the two numbers, and let's just look first for the prime factorization of 36. Prime factorization of 36, if you remember from the last lesson, we just break it up. There's many different ways to break up 36. I could choose 2 and 18, or 6 and 6, or 4 and 9. And in this case, I'm choosing 2 and 18 just because I find even numbers pretty easy to divide. So I can continue my factor tree such as follows. Now the prime factorization of 48, I'll try a different way. Let's try 4 times 12. I don't know if you thought of that one. 4 breaks up into 2 and 2. 12 breaks up into 3 and 4. And then 4 breaks up into 2 and 2. Again, regardless of the way that you're building your factor tree, will always get the same prime factorization for the two numbers, provided you do your divisions correctly in your factor trees. So if I look at the prime factorization of 36, 36 is the product of 2, another 2, another 3, and then another 3. I can just check my work because 2 times 2 is 4, 3 times 3 is 9, and 4 times 9 is 36. It's a good way of checking your work just by multiplying it through. In this case, I am not going to combine it into exponent or power form because I want to look at all the different possible prime factors that exist. Now the prime factorization of 48, I look at my numbers and put them in numerical order. I have 2, another 2, another 2, and another 2, and I have one lonely 3 over there. So if we could see these prime factorizations, let me just check. 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 3 is 48. What I'm going to do is look for any common factors that exist between the two. Well, if we remember, the lowest common factor is the lowest number that will go into all of them. And that's always going to be 1. The lowest common factor will always be 1. 1 goes into everything. But in this case, now we also look at the other common factors that exist. And we can see that 2 is in both numbers. I'll change my colors just so that we can see that. The number 2 ends up being in both numbers. That means 2 is also a common factor of 36 and 48. Also, I see another 2 is a common factor. So which means this. Not only is 2 a factor of 36, a common factor of 36 and 48, but 2 2's, 2 times 2 is 4. That means 4 is also a common factor of 36 and 48. And if we follow along, I see a 3 here and a 3 over there. That means 3 is a common factor of 36 and 48. But also are any combinations of any of those numbers. So let's look at all the different common factors. Common factors, I always have 1. 1 is always a common factor between two numbers. Then I had 2. I also had 3. Now I have any combination of these numbers. I have 2 and 2, which is 4. So 2 times 2 is 4. I have 2 times 3 is 6. I also have 2 times 2 times 3. So 2 times 2 is 4, times 3 is 12. And as you can see, that there are no more other common factors because there are no more common prime factors in 36 and 48. There are no other numbers I can multiply by that are common. All the shared factors, a 2, and a 3, when multiplied together, give the greatest common factor. How can we make this a little bit easier is we can put it in a Venn diagram. So I'm going to draw a Venn diagram here. I'm going to put in all the prime factors of 36 and all the prime factors of 48. So I see the common ones, they share a 2, they share a 2, and they share another 3. So if I look at the middle part only, which I'll just change back to green, the middle part only, that's not green, the middle part only is what we call the common factors. So 2 times 2 times 3 is common between the two of them, and that makes the product 12. The greatest common factor of 36 and 48 is 12. Now we see there's a couple of other numbers that are still left over. So 36 still has a 3 on the side. 48 still has a couple of 2's on the side. Now what we can do with these extra numbers is that we can now look for the most common multiple of the two. Because we need to, for a multiple to happen, multiples need all the numbers of the original number, all the prime factors, because it needs to be larger than the original number. 36, a multiple of 36 must at least be 36, and a multiple of 48 must at least be 48. However, since we know a common factor, we could take the common factors and multiply them by the uncommon factors. So our lowest common multiple is the GCF, and the GCF was the greatest common factor found from the intersection of the three numbers. So the GCF times all the other prime factors that weren't used to find that GCF. So in this case, these are the leftovers, the 3 from the 36 and the 2 2's from the 48. So that means now my GCF was 12. My other prime factors, well, I had 3 that came from the 36. And then I also have from the 48, I had a 2 and a 2 that came together, or that were left over. So my final LCM, or my lowest common multiple, will be 12 times 3 times 2 times 2. I might need a little bit of calculator help with that one, but let's try it out. Well, 2 times 2 is 4, and 4 times 3 is 12, so 12 times 12 is 144. How can I check that my LCM, my lowest common multiple, is actually 144? Well, let's go through what we did last year, and we looked at all the different multiples of 36 and 48. So if we look and we skip count 36, we get 36, we get 72, we get 108, and then we get 144. If we look at skip counting 48, we get 48, we get 96, then we get 144. So if we look at the multiples of both 36 and 48, we find out that the lowest common multiple is 144. So let's just recap what we did, because it's a very jam-packed lesson. What we did was we took two numbers and we found their prime factorization. So which means the smallest numbers that multiplied together give that answer. We found out what was common between those prime factors. Between those numbers, and found out the common prime factors. All the different combinations of those prime factors are its common factors. When you multiply all of the common factors, so the shared 2, and the shared 3, I get the greatest common factor, which is 12. I can check that 12 could be a common factor, or greatest common factor, because it is less than or smaller than both of my original numbers. And 12 is, and it goes into 36 3 times, and it goes into 48 4 times. Once I have my GCF and I create my Venn diagram to find that, I'll put my uncommon factors, or the other ones that were not being used, on the side. Now my lowest common multiple is basically my greatest common factor times all the unused prime factors, because that will generate our original numbers again. We needed this extra 3 to get back to the original 36, and we needed this extra 2 times 2 to get to the original 48. So once we have all those numbers in, so we multiply the GCF times the uncommon factors, the 3, the 2, and the 2, I will now get the lowest common multiple of 36 and 48. So without having to actually list out all the different numbers or to try out different multiplications, I can use this method to find the GCF and the LCM of any two numbers. Now, a couple of things. If you notice that there is nothing in between that is common, the greatest common factor will always be 1, because that is the lowest common factor and it is a factor for all pairs of numbers. The LCM could be as great as the product of the original two numbers. If all of the numbers were uncommon, all the prime factors were uncommon, I just multiply all of the uncommon prime factors and I'd end up finding the lowest common multiple there. Try a bunch of examples. If you're not sure you understand, ask a friend for help or ask me for help. So I hope you got this lesson.